Hello, so we're going to be doing a couple of practice problems from each section in Module 4 or Chapter 4 in our book in preparation for the upcoming assessments. And we're going to be starting with Section 4.1, an introduction to rational numbers. Now I know it's just a fancy word for saying a number that I can turn into a ratio, and we see that word ratio in rational, right? A ratio is basically a fraction, okay? We're going to be looking more into that. We're going to be getting more into rational numbers in 8th grade and irrational numbers, but let's just kind of jump right into it. So let's look at number 1. We got 5/8, okay? By the way, this is number 1 on page 183. Now, the operation of all fractions is division, okay? Numerator divided by denominator all the time. So I'm going to go numerator divided by denominator. I'm going to use long division to find out the decimal version of this because it's saying write each fraction as a decimal and determine if the decimal is a terminating decimal, like the Terminator. It ends things, right? So we have to determine if it terminates. Let's see. So I'm like, all right, 8 can't fit inside 5. It's too big. So I'm going to put a 0 and a decimal point there. That allows me to put a 0 there. Now 8 goes 6 times into 50. It gives me 48. We subtract that. So now I'm just dividing as normal, right? Using long division. 50 minus 48 is 2. I get a free 0, by the way. 8 goes twice into 20. 8 times 2 is 16. We subtract that. 20 minus 16 is 4. Okay, I'm allowed a free 0. 8 goes exactly 5 times into 40, and 8 times 5 is 40, and I get no remainder. So 5/8 as a decimal is exactly 0.625, and it terminates, it ends at 5, right? So this is an example of a rational number, okay, because it stops, right? I can stop it and turn it into a perfect ratio, 5/8. Remember, a ratio is just another way of saying like a fraction, right? A part and a whole. All right, like a relationship between two numbers, yeah? Okay, so let's go to the next one. So let's look at number 3, which is 2/9. Now this is going to give us another kind of rational number. But first we're going to turn it into a decimal to see what number this is, okay? So remember, numerator divided by denominator. Numerator is the top, denominator is the bottom. So I'm going to divide them. 2 divided by 9. If you ever wonder, oh, which one goes where, I always like to think, the 9 is covered from the sun here, and now it's the 2's turn, right? So they take turns under the shade, okay? So 9 can't fit in 2, it's too big. So once again, put a 0 there, decimal point there. That allows me to put a 0 there. 9 goes 2 times, it fits twice into 20, right? Which is another way of saying 20 divided by 9. You know how many 9s in 20, right? That's division. So I'm like, all right, 9 times 2 is 18. Subtract that. 20 minus 18 is 2. I get a free 0. 9, once again, goes 2 times into 18, right? And 9 goes 2 times into 20, and 9 times 2 is 18. We subtract that. Now you're going to see a pattern, right? There's a pattern here, right? 20 minus 8, get another free 0. It's just going to keep going, right? I can do this, for hours, and it will just keep happening. So I'm like, all right, cool. At this point, I know that the 2 is going to keep repeating. It's a repeating decimal. That allows me to put a bar on top of the digit that repeats. It's the 2 that's repeating, so I'm putting a bar on the 2. So therefore, 2/9 is 0.2 bar. Okay, that's called a bar notation. And you truncate or you drop everything else. So the decimal of 2/9 is 0.2 bar. That is a rational number, by the way, because we can stop it. We can stop it and turn that into 2/9. Okay, we put the 2 as the numerator, 9 is the denominator because it's in the tenths place, but if it has a bar, you just subtract 1 from whatever place it's in. So since it's in the tens place, we subtract 1. But you don't need to worry about that part. You'll be looking at that in 8th grade. But all you really need to know is that 0.2 bar is a rational number, okay? And it's the decimal version of that. Cool. So let's write -1 over 33 as a decimal. Now once again, we're going to do numerator divided by denominator, and we do have to remember that this is a negative fraction, therefore it's going to be a negative decimal, because both are going to be the same number but kind of different versions of that number, okay? Now I'll do 1 divided by 33. Okay, now I'm going to start dividing. 33 definitely can't go inside 1, right? So I'm going to put a 0 here, a decimal point there. That allows me to put a 0 there, but still 33 can't go into 10, right? I have to add another 0 there, but if I do that, once I add another 0 beyond the 0 that I'm allowed, I have to put a 0 up here. Now 33 can go into 100. It goes in exactly 3 times. 33 times 3 is 99. When we subtract that, 100 minus 99 is 1. Once again, put a free 0. I get a free 0. But then if I have to add another 0, I got to buy it by paying a 0 up here. Okay, and that allows me to put 1 here. All right. Now 33 once again into 100. So 100 divided by 33 is 3. Okay, 33 times 3 is 99. Or it goes in 3 times into 100, giving us 99. 100 minus 99 is 1. And by the way, this is going to keep happening, right? Because I get a free 0, it still won't fit. Got to, buy a 0 by putting 1 up here, then 1 here. And it's going to happen again. 33 goes 3 times into 100, and etc. Okay? Now, it's the 0 and the 3 that's repeating. Therefore, I'm going to put a bar on top of the 0 and 3, because those are the digits that are repeating, and I'm going to drop everything else, and we of course can't forget our negative sign, and so we get, the decimal version of -1 over 33 is negative 0.03 bar. Once again, this is just the decimal version of it, okay? The only difference between a decimal, maybe I should talk about this in some other video or something, but I don't want to get too wrapped up in this, but both decimals and fractions are talking about parts of numbers, right? Because not every number is a nice whole number, right? I always like to give the example of like your age, right? Think about it. You're only exactly some age. Like most of you are like, like between 13 and 14, right? That's the key. It's only on your birthday that you're exactly 13, right? Everything after that, you're between 13 and 14, so you're 13 and then part of a number, right? 13 and a half or 13.5, right? So that's where, 0.5 is the decimal, and then 13 and a half is the fraction. So do you see how both are like different versions? Decimals just turn a number into 10 parts, okay? From the deci is like 10, right? That's, okay, sorry. Now I'm going on this. I might as well really finish it because I've already started and I'm not going to do another video. So this indicates 10. So a decimal just turns a whole into 10 parts. A fraction can be into as many parts as I want. Like look at this one. It's 1 over 33, right? It's cut up into 33 parts. So so that is really the main difference between a fraction and a decimal. One is cut up into 10 parts, and then the think of a number line, right? If it's cut up into 10, and fractions can be cut up into as many parts as you want. So just different versions of that. All right, I'm gonna stop that tangent. Anyway, so that's the decimal version of -1 over 33.